Hello, welcome to this lecture video. So today we will be discussing elementary operations. So we say that it is an elementary operations, or the operation is an elementary operations. We can perform these operations routinely in a system's linear of equations. And what are these operations? So first, let us consider that it is possible for us to interchange two equations followed by, we can multiply one equations by a non-zero number. And the last one is, it is possible for us to add a multiple of one equation to a different equation. Okay. So as mentioned, it is said that operations are elementary operations if we can routinely perform the following. So it is possible for us to interchange two equations. It is possible to multiply one equation by a non-zero number, and it is possible to add a multiple of one equation to a different equations. So let's have, for instance, this example. So we have 2x plus 3y is equal to 8, and x plus y is equal to 3. So using our elementary operations, we are going to determine what is or are the equations of these systems of linear equations. So what we need to do is to perform some operations, like, for instance, so we will convert this into augmented matrix first. So this is converted into 2, 3, 8, and 1, 1, 3. So this is the augmented matrix form. So first, our objective, we can actually interchange the first row and the second row. But just in case we do not like to interchange this, the first method is always to make sure that our first row, the first entry is equal to 1. So to do that, so how will we remove 2? Because our objective is to make this equal to 1. So what operation do we need to do? So we can perform multiplication. So as mentioned, you can multiply one equation by a non-zero number. So first option is you can interchange row 1 and row 2 so that the first entry is 1. Second option is to go first with multiplying our values in the first row to a non-zero number so that the first entry will become equal to 1. So let us do the second option. So what will we do? We are going to multiply the first row by 1/2. So if we multiply 1/2 to 2, 3, and 8, of course, the values that we're going to come up will be equal to, so we have 1, 3/2, and 4. So this is equal to 1, 3/2, and 4. So the new augmented matrix now is equal to 1, 3/2, and then 4. Of course, we have the same value here, 1, 1, and 3. So what will you do now with 1, 1, 3? So in the next row, we can actually add -1, the first row, to the second row. So let's add -1 to the first row to the second row. So what will be the next value here after doing that? It will become, so we have 1, 3, still of course 1, 3 halves and 4. And then for the following, it is 0, -1 half, and -1. So what did we do? We add -1 times the first row to the second row. Okay, let us clear our drawings. So please take note of our value: 1, 3 halves and 4, 0, -1 half, and -1. Okay, next. So how will we deal now with 1, 3 halves and 4, and 0, -1 half, and -1. This is -1. Okay, so what's next? So we can actually multiply the second row by a -2. So if we multiply this by a -2, because we wanted that this will become 1. So our objective is, of course, for the first row, we want that the first cell will be equal to 1. While for the second row, the second cell will be equal to 1. And the first cell, this one I'm referring here, it must be equal also to 0. Because what we wanted to get is the value of x and y. So as you can see here, if we are going to place 1 here, it means that this represents the value of x. While for the second one, if we disregard now, or we try to figure out how we can make the first cell into 0, it means that we are finding ways to remove the value of x, so that what is left is the value of y. So to do that, we are going to multiply -2 to our row 2. So that is -2 r sub 2. So let us do. So of course, let's retain the first one, 1, 3 halves and 4. And then the next one, -2 multiplied by a 0 is of course 0. -2 multiplied by a -1 half is 1. -2 multiplied by a -1 is +2. So this is now our values. Now, what will we do to remove 3 halves? So, or what will we do to make it 0? So it means we are going to add -3 halves times the second row to the first row. Or this can actually be written here as x plus 3 halves y is equal to 4. And this is y is equal to 2, which means you can just substitute the value of 2 in place of y here. So you are going to get the answer x. So if we will substitute it into 2, it will become x plus, let's see, x plus 3 is equal to 4. It's 3 halves. So 3 halves multiplied by 2 is equal to 4. Cancel, cancel. X plus 3 is equal to 4. And then we can actually double check it. But let us see what happens here. Or if we are going to continue it, so let us disregard this part anyway. So what if we will just continue solving it? Let's see. So what will you do to remove 3 halves? So if we are going to add 3 halves, negative 3 halves times the second row to the first row. So let's do that. It means that negative 3 halves R2 minus plus the R1. So to do that, what will be the result? So if we are going to multiply negative 3 halves here, so this will become negative 3 halves, and the our 2 here will become negative 3. So did you see that? So let us just show that. So it will become, so of course it is a 0. It will become negative 3 halves, and then negative 3 halves plus at multiplied by 2 is negative 3. And then for the value above, it is 1, 3 halves, and 4. So if we add this, so the result is, if we add this, the result is 1, 0, negative, 4 minus 3 is 1. So 1, 0, 1. And of course, we have the same value here, 0, 1, and 2. So we just showed it here that what will be the value of r sub 2 if we multiply it in negative 3 halves. And then if we deduct it, so the result is 0, 1, 2. So which means the answer is x is equal to 1, y is equal to 2. So if you substitute that value in our original equation and obtain the correct answer, so which means it is correct. So this is actually already called as reduced row echelon form. So we are trying to simplify. So it is a reduced row echelon form. And since we obtained one answer here, one unique answer, which is x is equal to 1, y is equal to 2, it means that our matrix is, or rather our linear equations are said to be equivalent. So again, so we say that it is said, the two system linear of equations is said to be equivalent. So because they have the same solution. So the x in our first linear equation is the same x in our second linear equation. So just to show that again, we can actually go back and substitute. So we have here the 2x plus 3y is equal to 8. X is equal to 1, y is equal to 2. This is the computed value. So 2 times 1 plus 3 times 2, you will get 8. It is correct. Now, for our next equation, it is x plus y is equal to 3. So which means if we substitute 1 in place of x and 2 in place of y, you will also get 3. So the answer is correct. So as mentioned, we call this as equivalent. So thank you for watching.